architecture series. We'll be discussing today why mobile requires a four-tier architecture, and we have the VP of Product Management at Convey, Jiku Venkat, who's going to be presenting to us. So first, I'd like to invite everyone to ask questions that you have in the questions tab that you should see on in your webinar viewer. And I'll be keeping track of the questions that we get, and we'll answer them after Jiku's presentation is done. So we'll hold on to questions until the end. And so without further ado, we're going to do a couple of introductions.
Okay.
Go next slide. So I'm Caroline Murphy, and I'm head of product marketing here at Convey. But I am not the main show today. We're here to listen to Jiku Venkat, who's our VP of Product Management at Convey. And so with that, I will hand it over to Jiku.
Thank you for the introductions, Caroline. And once again, I'd like to welcome you all to this webinar. As Caroline mentioned, this agenda that we put together is really designed to leave you all with a good understanding of the lessons from history. What we've seen in the past, talk about how mobile is different, what the needs of mobile are, how a four-tier architecture is necessary to meet these needs, why it's needed, how mobile backend as a service, or MBaaS, fulfills crucial needs of this four-tier architecture. And we'll end with a little story about how one company has used the four-tier architecture and built a very successful application. And then we'll have time at the end for Q&A, as Caroline mentioned. So we'll get started here right away and look at history. So our industry has been blessed with the fact that we see constant changes, right? Change is pretty much the norm in our industry, and this is very exciting because it drives a lot of innovation. But change, again, is very, very hard, and most of these changes are driven by hardware, and the software takes a while to change. We've gone from the very large mainframes that we had with very large monolithic applications to when we saw the next wave of the mini computers, which led to smaller applications. We began to see how applications could be split up into smaller services, and then came the onslaught of the PCs and workstation, and that drove the need for a different type of architecture on the application side, really a client-server architecture to accommodate the needs of these really thick clients and the local area networks that were connecting to them. Again, this was a very hard transition. It took a lot longer for the software to transition than the hardware. And then came the World Wide Web, right, which was very, very rapid. You went from, and each time, each wave brought with it, larger and larger set of applications. You would have had a few hundred applications, mainframe did a few thousands to hundreds of thousands in the internet era, where the applications, in order to keep up, had to quickly move to a three-tier architecture, which we'll talk some more about here shortly, and you had hundreds of thousands of applications. The mobile wave is a lot bigger. In fact, some would call it not just a wave, a tsunami, because you're now talking about millions of applications, billions of devices, and the needs of mobile being very, very different is driving the change for a new architecture. Throughout each of these transitions, we realized that even though the hardware changes and changes very fast, in order to take advantage of the hardware and the operating system, you really need applications. It's really about the applications because the applications deliver the benefit to the end user, and you really need to keep pace with these changes by changing the application architecture. This is no different with mobile, right? The mobile applications are very important. There's a lot of them, like I said, and mobile applications have very unique needs that are different from their web counterparts, and we'll examine some of these needs and why and how they are different. So first off, the mobile client, right? The mobile client itself is very different. The connectivity is very different. It is a thick client, much like we are used to in the PC days, but it's connected very differently. You might be on a 3G network at one point. You might be on a Wi-Fi. You might switch between the two in a few minutes. And you might be offline at times as well. So it's very important to be, for any application architecture, to be able to deal with this transient nature of connectivity. The other important thing is synchronization of data. In this transient network situation, how do you make sure that the data that the application needs is front and center and engaging the user at all times? The other reason why the mobile client is different is because it's omni-channel. The same user might be on multiple devices at different times, and there are many different types of devices, each with its own network connectivity options, as well as screen size differences, all the way from a watch to a wearable, other types of wearable devices, to devices that are like your thermostat, with the onset of the Internet of Things, to 4-inch screens on smartphones, to 10-inch screens on tablets, to 12-plus-inch screens on laptops, and you see everything in between as well, and crossovers and hybrids that have different screen sizes. You also, a mobile app developer or a hybrid app developer has access to a very diverse set of tools, because the skill sets are all different with these developers, and they use the tools and languages that they are comfortable with, whether that is native iOS, Java on the Android platform, using JavaScript, and then making that mobile app available on the phone, or doing hybrid development, or a C# developer developing in C# and having that cross-compiled to either iOS or native Java. So the tools are very diverse, and we need to be cognizant of this fact and be able to handle that. The mobile experience is also very different. It's very contextual. What kind of network is present, where am I, on what network, what is the current context of what I'm doing, and it's very user-centric as well. Given this context, what is the user trying to do, or what is the user doing? So again, the application architecture needs to comprehend this. Finally, the application needs to be very engaging to ensure a good mobile experience, because engaging your end user drives the success of your application, drives dollars, drives some of the key objectives you might have with your application. So it's very important to provide a very engaging experience, because a lot of your users are used to that from the consumer side and applications that they've downloaded and used on their mobile devices from that consumer side. Next up is data, right? So we've talked about the client, the user experience on that client. The next thing is, what type of data does my application need access to? How do I get that data to the device? This is especially true in a business enterprise application, or those use cases, because this data is typically behind a firewall when it comes to enterprise systems of record, and mobilizing this data is very, very different because you need to deal with the network, the transient nature of the network, the difference in display sizes, and so on and so forth when you're mobilizing data. And not only do you need access to data that are stored in the enterprise within your firewall, but you also need access to data from third-party services and be able to correlate that with your enterprise data, again, to provide the experience needed for these mobile applications. And part of mobilizing data is also to recognize user identity. And user identity on the mobile side is how do I connect to enterprise identity sources, identity providers, whether they are Active Directory based, LDAP based, or any of the other protocols or proprietary identity management systems that exist within the enterprise. And those need to be mobilized as well and made available to the client. Lastly, you need to do all of this in a very, very secure way, right, to ensure that any security compliance constraints are being met while you're mobilizing data, mobilizing identity, and so on. And since the client device itself here might be untrusted, it's again very, very important that this data is accessed in a very secure and controlled manner. So those are some of the reasons why mobile is different. The other big thing with mobile is that the pace of mobile is very, very different, right? There are your business lines of business or business users that are clamoring for applications, and they want them fast because they are used to getting them fast. They want them to be updated very fast because, again, they are used to that from other applications that they download and use from the consumer side. So IT, which is trying to get these applications delivered, needs the right architecture to do this job because they need to ensure that the backend infrastructure, the backend services that are very stable, very secure, and they work hard to make them stable, secure, and available for the web, all of that is still maintained. IT also lacks some of the mobile skills and experience, and this becomes a challenge. And as the business wants to build apps and wants to build them fast, they tend to do this in a one-off way where they go ahead and build the app, they make all the connections, and then it becomes very, very hard to maintain and manage going forward. The other important thing with management and maintenance of the application is to keep up with the introduction of new features in the mobile operating systems, technology changes on the device side, and making sure that the application are up to date. Also is challenging, and to be able to do that quickly at the pace that is expected of mobile is another key challenge. So if you look at mobile development, right, a person trying to do a mobile app is typically working in a very agile software development lifecycle. What this means is that they conceptualize, they put version 1 of the app out there, and they continue to iterate very, very rapidly. You're talking iteration cycles that happen in weeks. You launch a version of the app, you enhance it, you launch another version, you get feedback from the user, and then you put out another version, and this is happening in a very rapid iterative process. The backend systems that provide data to these applications and the infrastructure for these applications, however, operate at a very, very different with a very, very different development life cycle. So that life cycle uses more of a waterfall approach where you design, you conceptualize, you plan, you build, you test, you deploy, and then you iterate. But this is a very long cycle. So you're talking about weeks at the top here while you're developing, deploying mobile apps, and months at the bottom. And it's anywhere from a 9 to an 18-month cycle to make large changes to backend systems. And it's a very deliberate approach, again, because you want to make sure that these changes continue to maintain the stability, the security, the availability, because you work very, very hard to get these systems to this place, and you don't want to disrupt that. So somehow you have to figure out a way to decouple the development of the mobile apps from the maintenance of these back-end systems. And how do you do that? If you look at the traditional three-tier web architecture, right, you have a client tier, which is essentially the web browser. It took a while to go from the client-server architecture to this three-tier architecture, but people eventually realized that they needed an application tier to separate business logics, because you did not want to have the business logic either residing in a data tier along with your database. Neither did you want your business logic tied to the client and to the browser, but you wanted to separate that out into an application server. We saw that change. So why can't we use the same architecture for mobile? Why doesn't the three-tier architecture work for mobile? The quick answer to that is, sure, you can make this work to meet all these mobile needs that we just talked about. Is it hard? Absolutely. It's very hard, because you take this three-tier architecture and you fix it for mobile. You first have to, at the client tier, realize very quickly that it's not simply the various types and versions of desktop browsers that you have to deal with, but you have to deal with mobile browsers and how they behave and their display sizes and different variations of these versions and platforms of these mobile browsers. If you're building a hybrid application, for example, or if you're building a native app, you have to worry about the native application, its environment, libraries, and all of the different mobile platforms, from iOS to Android to Windows to BlackBerry. And you want to have the appropriate libraries in place. And in the application tier, you have to take the existing application server business logic that you've already written, make sure you can enable the data and protocol translations. For example, your web architecture may have exposed the data using SOAP as a protocol and XML as the data representation. Your mobile client developers like to consume data with using a RESTful protocol and a JSON data representation. So you have to do those translations in this application tier, and you have to build it again for every mobile app and access to every data source that you want to pull from this tier. You also will need some mobile-specific logic to do things to account for some of the things mobile needs that we talked about: the context awareness, the omni-channel nature of mobile, different display sizes, to do different to change the operation that you're performing on the back end based on the network state, to be able to do caching of data, access to location services, third-party location services, access to push services. You'd have to build all these new services that you see here in orange here, and all the connectivity that you see here in orange, across multiple platforms and across multiple device types as well. And finally, in the data side, you have mobile-specific data, mobile-specific files that you will want to store, and you need to find a place to store them. And finally, you need to provision the infrastructure for all these things in orange here and be able to scale that infrastructure because, like I said earlier, mobile is going to introduce a very, very new dimension to scaling because you're really talking about billions of devices that want to connect. So you can fix it, but it gets ugly. Even for one application, gets very ugly for multiple applications across multiple platforms, and the maintenance of this becomes a nightmare, and you're really disrupting your backend system. Your security is at risk, your scaling is at risk, performance is at risk, and most of the customers that we talk to very quickly realize that there is a problem here, and they want to step back and look at this. And when they step back and look at this, they realize that we talked about the waves, right? Each wave brings a new application architecture, and when you step back and look at it, just like you went from client server to three-tier, or from a monolithic application to a client server, mobile is driving the need for a different type of tiered architecture. And it's not just customers, analysts are realizing this as well. In fact, it was Forrester that coined the phrase and introduced the concept of this four-tier architecture, which we'll discuss in detail here. The four tiers being the client tier, a delivery tier, and we'll go over each of these tiers in more detail in the subsequent slides here, the aggregation tier, and the services tier. So if you start with the client tier, right? The client tier is all about the different types of mobile clients that are out there, from phones to wearables to the Internet of Things. And the client tier is also responsible for the user experience to make it engaging and make sure that the data and everything you need for the application is delivered to the client in a very responsive and high performance way. The delivery tier is a new tier that is introduced that basically is responsible for optimizing the content for proper display on the device. Again, you're going to deal with devices, everything from devices that are completely headless, as in they have no display, to devices that have very tiny displays, all the way to the traditional desktop devices with large displays. And you want to ensure that you're optimizing the content delivery based on display size of this device. You also will need to cache the content to ensure that if these devices are offline, they still have access to the data they need when they are offline. And also, even though they might be online, they might be on a very poor network. And to ensure performance, you again want to do acceleration of the data with caching. And you also want to drive personalization, which again you can optimize in this delivery tier, where based on the context that a user is in and what they are doing, you get that with analytics. You can do things differently, prompt the user differently, deliver data in a different way based on user behavior. Make sure the things that they are accessing frequently appears on top, things of that nature. All of this optimization is done at this delivery tier. The aggregation tier is really where you're starting to decouple, and we'll see this here in a second. The aggregation tier is responsible for taking existing data sources, aggregating this data and making it available to the delivery tier, so you can do the tweaks and modifications that you need to enable delivery to the client tier. And you want to have an easy way for both client developers and people working in this delivery tier to discover what is available, access to service documents that show what types of data is available in what form, what endpoints, and so on. And also to perform the protocol translation. We talked about this, whether it's XML to JSON, SOAP to REST, those types of translations need to happen at this aggregation tier. And finally, you have the services tier, which is your existing tier from the client server architecture that connects to your systems of record. Any other enterprise services that you have, for example, an identity provider is a service that you have available across all your applications. That's another system of record. So it's not just data, but security and other type file services and so on that are available in this services tier. In addition, this services tier now also needs to add secure, controlled access to third-party services, whether that's an urban airship to do push notifications, to do messaging, SMS notifications, to do email notifications, to provide access to files and content from third-party services like Box. All of this happens in the services tier. By breaking things into these different tiers, you're really able to handle some of the needs of mobile that we talked about. The most important one being this thing we talked about, where you want to decouple the development, where you want to ensure that the mobile app development happens in a very, very agile manner, releasing apps every few weeks if they want to, every day if they want to, without disrupting your backend systems. And by breaking things into these 4 tiers, you're separating these concerns, and separating and abstracting these things helps you. And the way this works is that your client tier and your delivery tier can operate really what we call front-end development that can operate at digital speed. It's very agile, it's fast. Your front-end developers have access to client libraries that give them access to all the services data that they need from the backend via these client libraries. And with the delivery tier, you can build the caching, the acceleration, and the optimization, as well as the analytics that are needed to build very, very rich applications. And on the back end, you take your existing services tier and you add to that an aggregation tier that aggregates all the data, aggregates all these services, does the necessary protocol translations, and also provides a way for you to write business logic to be able to provide this data in a way that can be consumed by the delivery and client tiers. And the important thing is, because you've separated these tiers and they have well-defined interfaces, your backend development can continue to operate at a much more deliberate pace and preserve the stability, security, availability that you're used to. And you can also control how the front-end developers get access to these services and these data, so you can ensure the performance, not just of the new applications that are coming on board, but also your existing applications, web applications that need to operate on the same backend data sources and services. So that's how a 4-tier architecture supports what we call, what we and others call two-speed IT, and an important pieces of that are really this aggregation layer and the microservices in this aggregation layer that separate, that allow you to separate the rapid front-end development from a more stable back-end development. So it's important to understand these benefits. Now the next thing is, what is mobile backend as a service, and how and why does it fit into this 4-tier architecture? So if you look at the tiers again, the client tier, the delivery tier, aggregation, and services, backend as a service really provides a big portion of the client tier, the delivery tier, and the aggregation tier. How does MBaaS do this? In the client tier, you have libraries across all of the devices that you see there at the top of this slide, whether that's a watch or a smartphone, or you're building a hybrid app that runs on the phone as well as a desktop. You have libraries across all these devices. So you're not just restricted to a single development platform or a single type of device. And MBaaS will provide libraries for all of these platforms, so your developers are free to take advantage of these services across any language, any IDE. And these libraries provide some very critical features, so they don't have to rewrite these features each time they are developing a new app. User management, for example, logging in, logging out, resetting password. These are common features for every mobile application, and the library provides that, again, across all these platforms. Access to location services, offline caching without having to write code to cache data and then manage that cache and the policies to manage that cache. That is readily provided for you. We talked about security and how mobile is different because the device is untrusted, and from a compliance standpoint, you need to ensure that your data, corporate data, is secure when it's cached on that device. So the libraries to perform data encryption, and that's provided in this client here with the libraries. Synchronization of data. As data changes in the backend or front end, how do you keep the data in sync? That again is provided via the library. Network management, to be able to sense what the current network state is and then take action on that. Those are some of the key features that an MBaaS provides in the client here, again, via library, SDK, and across all platforms that a developer may want to use. So the developer with this library, armed with this library, really is completely abstracted away from any changes in the pace of development that happens in the back end. In the delivery tier, an MBaaS would provide services to do push notifications with just configuration, zero to low code, access to storage for persistent data, as well as files, the scaling of the entire infrastructure required for mobile. As the demand ebbs and flows, you want to make sure that your infrastructure can scale along with that, because you no longer can afford to build for peak demand, right? Because the scale is very different, and it can become impractical very quickly in terms of how much infrastructure you have to stand up. And having this as a service gives you the ability to scale this on demand. The acceleration of content via CDN, way to do business logic specific to mobile, so you can tweak your existing data to fit the needs of mobile. Access to identity providers, multiple identity providers, and the analytics. And then in the aggregation tier, an MBaaS solution would provide the connectors that connect to your existing systems of record, existing services like identity services, whether they are a SQL database, enterprise service bus. These connectors would convert these to a RESTful JSON format, so it can be easily consumed in the delivery and client tiers. Or if this data is coming from an API management solution or an API gateway, the MBaaS connects into that as well. And identity from multiple sources, whether that be SAML, LDAP, etc. So this is how mobile backend as a service fits, and key features in each of these tiers that mobile backend as a service provides. So why do you use MBaaS? You could do this all yourself. Obviously, we talked about the disadvantages of doing this, retrofitting the existing web architecture. You could do it yourself and do a 4-tier architecture from scratch yourself, but why would you, right? Because we are an MBaaS solution is giving you all this, and leveraging experiences across multiple customers and providing this to you. Whereas if you build it yourself, it's going to take you a lot longer app development cycle. We've done some studies here internally and experience with our customers that indicate that a 12-month app development cycle could be shortened significantly to about 3 months because you have access to these features via libraries. You have access to these pre-built services across all these tiers, and most importantly, that you have it available as a service, so it's scalable, secure, fully managed by us, so you don't have to worry about the operations and management of this as well. So that's the reason you want to use MBaaS, and you save a lot of time. Obviously, that means you're saving a lot of money as well, and you get applications to market much quicker. So we'll end with a story of a client of ours here, which is a top 5 pharma company, and they wanted to build this application. It's called an e-detailing app, which really their objective was to drive sales productivity. They have these salespeople walking around to prospective client offices. They are not always connected to a network, and typically they travel with an iPad or a smartphone. And to improve their productivity and their engagement with the prospective client, which is a physician, they also needed to ensure that the compliance needs of these applications are met, be able to educate their clients prior to sale, support multiple sales reps across multiple geographies, where each geography has its own compliance requirements for this type of information, thousands of sales reps, and they wanted to make sure that content is very up to date and delivered via a CMS system, and be able to track what a salesperson is doing on their device and how they engage with the customer, and to be able to document their visit. And obviously, the business user wanted this really fast. They wanted the delivery of this app in 4 weeks, and when we started talking to them, they were still formulating the requirements. They didn't quite have all the requirements. Some of the requirements were very ambiguous. So they bought into using this 4-tier architecture, using an MBaaS platform for their client delivery aggregation tiers. So the native app written in iOS. They leveraged the client tier for user management, network, the encryption of the data, because again, like I said, this is a very compliant type of situation. Their sales reps are walking into offices with no network, and therefore we needed to provide offline caching, utilizing this client tier, and obviously location was very important here because you had to do different functions based on your location, both from a geography that you were selling in as well as what you were selling. And there is a context tier as well that they took advantage of, where they had local data stored within the MBaaS for certain mobile specific settings and so on how, for example, what type of data gets delivered in what geography. Those types of settings were stored in the context tier. They wanted all the analytics from this tier, so they could report out on the activity of the salespeople, notifications of content changing, using engagement and business logic as well, to be able to ensure that the right type of content is being delivered, whether the sales rep is on an iPad or a phone. Their data gets delivered differently. The volume of data is different. The attributes of that data are different. And then this all had to be scaled, secured, managed through different stages of the life cycle, from dev to test to staging to production. multiple environments and so on. And MBaaS provided all that for them. And finally, the aggregation tier. So all of this data, sales data, the content, was coming from enterprise sources like Salesforce. So building connectivity in the aggregation tier to these data sources and identity management via LDAP. So they built the app, they bought into the architecture, got tremendous value because now their salespeople can walk into these physicians' offices and always have the latest data. By changing the content on the back end, you can ensure that they are following the latest, greatest updated process for this. And we're able to keep track of the sales process as well, right? Ensuring compliance, being able to track the data, etc. And it integrated again with the system of record that they have, which in this case happened to be Salesforce. The most important benefit value that they got from this is when they originally looked at their needs, their requirements, they thought to support these 2,000 sales reps across 5 different countries and/or territories, they were going to build multiple apps. By taking advantage of the mobile context tier and doing the right things in the aggregation tier, they are able to, in the mobile context tier, be aware of the location that the salesperson is in, and then with a single application, be able to deliver the right type of data, the right type of attributes that are required for that particular territory or geography. This was huge for them because this really would have resulted in multiple applications. And even though they were only running on a single platform, Apple right now, they have room to grow as well. And this would have been an enormous task for them. So by reducing this to a single app is a tremendous saving in cost. They were able to deliver the application very quickly and meet the needs. So to sum up here, before we get into QA, so it's important to learn these lessons from history. Each wave is again driven by hardware. The current one is being driven by mobile and the Internet of Things. Every time we've had this type of transition in the industry, we've revisited the application architecture, going, for example, from client server to 3-tier, the same type of transformation, again, happening when we go from the classic 3-tier web architecture to this mobile architecture, 4-tier with MBaaS. So that's it. Again, thank you all for joining the webinar and patiently listening to me here today. I think we'll open it up for questions, Caroline.
Yeah, we've got a number of questions. So I'm going to start right at the top. So the first question that we got in was about some Convey libraries. So the question is, do Convey libraries include native Windows, C# with Visual Studio, rather than Xamarin or PhoneGap?
Right now, the Convey libraries support Xamarin and PhoneGap. We don't have the native Windows libraries because that has not been a big need from our current customer base, but we are constantly visiting the platforms we support, and one of our big differentiators is the breadth of platforms that we support. So assuming there is sufficient demand for it, it would be easy for us to go from our current Xamarin, which is really built off of a C# foundation, to move to native Windows.
Perfect. Okay, so our next question is, what about real-time access to data and services?
So yes, you can have access to real-time data either through the platform. I don't know if the question is whether they want access to real-time data through the Convey platform, or they want to be able to store real-time data in the MBaaS platform and then access it in the app. Both of these are possible in the platform. The latency through the platform is very, very small, so it should be possible.
Okay, great. Next question was about push notifications. I answered this one already, but it probably bears repeating. So how are push notifications handled, and how does Convey maintain the device information?
So Kinvey gets access to device information from the requests that are made through our library, and you can do configuration of the push notifications in our backend, either manually or via business logic. It can be triggered, and the device identity is available when you write the business logic through a Kinvey API.
Next question is probably a little bit deeper here. So it's asking about our technology stack. So what is Convey's technology stack?
So Kinvey's backend technology stack is based on Node.js. Most of our components are written, our services are written in Node.js. So the entire service runs off Node.js. All of the business logic functionality is also in Node.js, and then we have persistent data that we keep in MongoDB, and we use a standard file store for storing files in a secure way.
Okay, so got a bunch more questions coming in here. So I'll go with this next one. This is, you talked about 4-tier architecture for mobile content delivery. Would the same architecture work for big data capture for mobile clients, or would a more simple model work?
So to understand the question and what he's alluding to, or he or she is alluding to correctly, it's, are these tiers really layers in the architecture that add additional latency, especially when I'm dealing with big data and data from the Internet of Things? You can optimize, right? So you don't have to use every feature in every tier when you look at your data flow. In order to optimize your data flow, you don't have to use all of these tiers, and each of these tiers don't necessarily have to add additional latency for your specific use case. And I know the IoT use cases, because I've worked with them, require a very minimal type approach to ensure that data gets from source to sink very quickly. And again, this should be possible because these tiers and then the features within these tiers are all optional, right? So you use it when you need to. And if you need to collect data from an IoT device and dump that into a persistent layer, or going the other way around, you should be able to do that pretty quickly.
Great. Another question here is, can they replace an ESB?
Our intent is not to replace an ESB. If you already have an ESB in place, our intent is to use it. But if you're trying to introduce an ESB into your architecture and you don't currently have one, then you'd have to look at the needs of your application to see if the existing MBaaS features just are likely going to eliminate the need for a ESB, but I can't speak that for all use cases. So it'd be very use case dependent.
Let's see, the next question here is, can this mobile backend be linked to a web application?
Absolutely. Linked as in you can develop hybrid apps that are both web. Really, it's the client tier that's going to matter. The backend can be shared between web applications and mobile applications. Absolutely, that's the intent. And the advantage of using an architecture like this. And if you're building hybrid apps, obviously on the client side, you can share the same code, because we support a lot of these HTML5, JavaScript platform for developing hybrid apps, whether that's PhoneGap or anything that's Cordova based that we support and have libraries for.
Let's see, our next question. What is the technology used for offline caching? Is it SQLite? Is there a limitation on storage of data in the client?
We use our own technology for storing and maintaining the cache. It is similar to SQLite, but it's our own technology for storing data that is platform independent, again, because we have to support multiple platforms. The storage limitation on this is really limited by the device itself and what storage it has available to that specific application. Otherwise, there are no hard limits from the MBaaS side.
Okay. Let's see. So does Convey support or provide Windows Phone libraries or SDKs for easy integration? I think that we covered this a little bit, but maybe it's helpful to reiterate some of the options for if you're trying to develop for Windows.
So if you're trying to develop for Windows, we have a lot of customers using Xamarin or any of these hybrid libraries that we provide. For example, we have customers using PhoneGap on Windows. We have people obviously using Xamarin as well to develop for Windows.
Okay. And then we've also got a question here. Does Convey support in-house or on-premise deployment?
Convey has multiple deployment options. There's a multi-tenant cloud option for our business customers. We also have our business customers can get a dedicated instance where the entire Convey instance is dedicated for their use and not shared with other customers. And we also have a third deployment option, which is an on-prem deployment or a customer-provided infrastructure, but still fully managed by Convey. All these deployment options, all three, everything is a fully managed and delivered as a service.
So we've got a question here about other MBaaS providers. So it says, compared to any presence in Seed Henry, what's Convey's competitive advantage? Price, technology, I guess, what are the differences really between Convey and a different MBaaS provider?
So the first thing I would say there is, this is probably a long answer. We have a whole set of competitive information against both these competitors and others. To give you the quick version to answer the question for this webinar, you can see us, contact us for additional detail. Happy to provide you. Convey really pioneered the concept of backend as service, really coined the term back in 2010. So we are a pure play MBaaS provider. That's probably the key difference between us and any presence or Feed Henry, where some of the MBaaS players that are out there come from more of a services background, or they come from the MADP world, where they started out as a application development platform or an IDE, which is what Feed Henry was, and then layered in backend services. We are a pure backend services player, very agnostic to the front-end development environment, and that is our biggest differentiator, and that's why. So we have a very rich set of features that are very, very focused on the one thing that we do and do really well, which is the backend.
Excellent. Okay, so I've got a question about failovers. Do you have failovers, et cetera, when delivered as a service for a specific organization? Do you provide isolation in terms of security and storage?
Yes, we have built-in failover capability. We deliver everything as a service. The underlying infrastructure is all cloud-based, so it comes with failover and disaster recovery for our large enterprise customers who demand it. And we've been audited multiple times by these customers, including some of these pharma customers that I just mentioned, for the level of isolation that we provide, both in terms of storage and network and other things within our multi-tenant cloud.
Great, and we'll take just a couple more questions here because we're coming up on the hour. So we've got, I see 4 more questions in here, so if anyone has any other questions, get them in quickly. So how is support for unit testing and integration testing?
So you can do, actually this is a great question, because you can sign up to the Convey console and you will see something called an API console, where you can actually test. We talked about these different tiers, right? So you can actually test what you're getting from an aggregation tier to use in an application, an endpoint that you're getting. You can do the testing right there in the console. The other nice feature that we also have is the ability for you, as a front-end developer, to define your data, model your data, create the endpoints that you desire to create the user experience that you want, and start building your app, and actually put mock data in the Kinvey data store to enable you to test the app during the early stages. And just by flipping a switch, you can, once the endpoints in the delivery aggregation tier become available, you can just flip a switch in our console and switch your data collection basically to the eventual endpoint. And this provides a way for you to do a lot of testing, both at the unit level and end-to-end as well.
Excellent. So our next question is, besides the client layer, would the other layers in the 4-tier architecture benefit from or require authentication and authorization?
Absolutely, yes. We have found, especially in the enterprise use cases, that you need both authentication and authorization to access enterprise data sources. And again, these are built into the aggregation tier because using the Kinvey SDK, you pass this token to the backend when you're requesting the data, and so you only get access to data that you're authorized to get access to.
Perfect. Okay. And how many systems does the Kinvey platform support out of the box in the services tier?
I assume the question is around how many systems, as in how many devices.
Yeah, I think what they're talking about is in the services tier, like how many connectors, like data link connectors, mobile identity connectors, does Kinvey currently support?
We don't actually have a limit on the number of connectors that you can hook up to an application. So in theory, you could have as many connectors as you wanted. So there is no hard limit right now.
And it might be helpful to talk about the ones that we have pre-built. We have some pre-built data link connectors and mobile identity connectors.
Yes. So we have pre-built connectors for all the common integrations that our customers have requested. For example, Microsoft Dynamics, Salesforce. These are all pre-built connectors that you can download, use as is, or modify the existing code to suit your needs. These are freely available. We have several connectors already available to SQL databases as well. And on the Auth-Link side, we have out-of-the-box support. So you have to do no additional coding, just configuration to support an LDAP identity provider, an OAuth identity provider, or a SAML-based identity provider. These are all just configuration on the Kinvey side. And again, we also have a reference Auth-Link connector that you can download and modify for your own purposes if you're building to some other identity provider protocol.
And then we have, I think we're going to take just one last question. So it says, what is your strategy to keep up with iOS and Android upgrades?
This is one of our big differentiators. We pride ourselves on the fact that we are always up to date with changes to Android and iOS. You can visit our timeline. I believe it's devcenter.kinvey.com/timeline, and you'll see updates to our SDKs, to our libraries, and we do that very quickly. The day the new OS update is announced, we already have the library fully tested and ready to go.
Excellent. So that is it. We're all out of time. So we want to say thank you very much to everyone who joined us, and hopefully you learned some interesting information. And we'll be sending out emails to everyone that have the links for the rebroadcast of this. And if you have any other questions, please feel free to reach out to us, and we would love to hear from you. And have a great rest of your day.